Hello, my name is Naol Ketema, and I'll be showing you my project 2.8, the Reverse Polish Notation Calculator. This project highlights the use of reverse polish notation, a mathematical system where operators come after the operands, unlike the infix notation we're commonly taught. The first example is 9 minus 6, but using RPN. Here is a quick run-through of all 5 example calculations. The RPN calculator relies on 2 critical concepts, stacks and binary expression trees. A stack is a last in, first out LIFO data structure, which is a lot like a stack of trays. It uses push and pop operations for adding or removing elements. Binary expression trees, or BETs, visually represent arithmetic operations, and in post-order traversal, the left and right operands are visited before the operator, directly aligning with the RPN. This principle is implemented in the code using stack push and stack pop functions. The calculator is built using an Arduino Nano, a custom one-wire keypad for the input, a 16:2 LCD for displaying inputs, results, and error messages. There's also 15-pin headers for the Arduino Nano, as well as one 16-pin female header for both the Nano, and also a 16-pin female header for the Arduino for the LCD. And there's also a 10k ohm potentiometer, and on the one wire keypad there's 16 momentary push buttons and 3 4.7k ohm fixed resistors, along with 4 1k ohm fixed resistor. There's also 4 screws for the PCB, as well as 4 stands, as you can see. And you will see the connections for the Nano and LCD appearing on the screen. The code begins with debugging enabled using hashtag define debug1, which allows a serial monitor to display different analog values. As you can see, for example, when we press number 5, the analog reading is 151, which is one of the thresholds, as you can see. One of the variables is the float current number is equal to 0.0, which temporarily stores numbers before they're pushed onto the stack. Integer stack size is equal to 0, tracks the number of elements on the stack, and then it triggers the error messages when there's a stack with less than 2 elements that are pushed on it, and when you try to use an operator, it will show stack empty. And if we just randomly press an operator, it will just keep it like that. The inner buffer stores user inputs as strings, while buffer index keeps track of the current position in the buffer. Specifically, lines 54 and 70 of the code allow for multi-digit inputs. And the multiple digits functions validates user inputs, checks buffer space, and then appends characters to the buffer. Once a number is complete, it's converted to a float using A to F and pushed onto the stack. This is the function that allows multiple digits, meaning digits with more than one digits that are more than one number, as in 2-digit numbers. So it's like 78 and 78. Let's say 78.2. Another error message that can pop up is when we divide any number by 0. For example, 5 divided by 0. As you can see, it'll show error, and it's because you divided by 5. The last one is error overflow, which means that the PCB can't handle more than 16 elements. So if we just put a bunch of elements on the stack, it'll say error reset, and you can reset it by pressing the equal sign. Another important concept is string to float, which is done through the use of A to F function from the stdlib.h library, which converts a string like 1.23 into a float that can be used for calculations. And the other one is float to string, which is done through the d to strf function, because after calculations, floats are converted back to strings using that function so they can be displayed on the LCD. AVR libc is a standard C library for AVR microcontrollers like the Arduino Nano, and it provides the access to functions like A to F and string handling and other low-level functions that are beyond the built-in Arduino tools. The project demonstrates how RPN simplifies arithmetic operations and showcases the practical use of stacks and expression trees in embedded systems programming. Thank you for watching, and I hope you learned something.